Okay. So today's the 28th, right?
Yeah.
Okay. What was the problem? It was f of x 3x minus x squared over 2x minus 2x minus 2. Very good. Perfect. Remember I just showed that part of the lecture from last time in which we used the long division or synthetic division, I don't remember which one, and we determined the quotient, and then we determined the remainder over the divisor. Perfect. So now here, obviously in descending order, and 2x minus 2. And now I'm going to ask you, like we did, it may have been the lecture before, actually. What is the degree of the top?
2.
Yes. Once you say 2, then I will factor out x squared. What is the degree of the bottom?
1.
Yes. So then I will factor out x. Now I have to be very careful and see what's left inside, so that this works. So what is left inside?
On top we have negative 1 or negative 1x. Or sorry, you put out x squared, right? So negative 1 and then x.
Very good, because x squared times x would be
Right.
good. And now I factor out x. What is left?
2 minus 2 over x.
Very good. Good. Now, remember, we are talking about infinities. So in any event, I should write x not equal 0 when I simplify, right?
Yeah.
Okay. Good. Here's my question now. I should not put the equal symbol. I should put just an arrow, because I can't really put the equal symbol. As x approaches, let's say, infinity. You do not have to do this on any of the tests. This is basically part of calculus. But I want to answer Joey's question. As x approaches infinity, or if you want x approaches negative infinity, whichever you want, it doesn't matter. What does this approach? Remember, it's type 2. We shouldn't think.
0.
Right, at infinities, it's type 2.
Right.
Higher degree in the denominator, at infinities, it must be 0. Good. So then I do have a negative 1/2 here, and I have an x in front. So that should be part of the quotient. Right? And now, as I say, x approaches infinity. Now, at this point in time, here, there are two different answers, though. Not for these two. For these two, no matter what, infinity or negative infinity, the answer will be 0. So I can even cover those. They're gone. But now there are two possibilities. If x approaches infinity, infinity times negative 1/2 will approach negative infinity. As x approaches negative infinity times negative 1/2 will approach infinity. So yes, you're right. That would be the slope. That's how we show what happens. But remember, I cannot write the equal symbol here. It has to be approaching. So now if you want to write, there are two options. As x approaches infinity, then x times negative 1/2 will be negative infinity. And as x approaches negative infinity, this will be positive infinity. Again, you do not have to do this. I was just answering Joey's question. Anything else? Anything else? Other questions for me? Anything you worked on before we look at this? Anything you worked on? Anything? So I'm hoping that you redo the problems we do in class and then the problems in the homework, right? So you don't fall behind. Any questions for me? As I said, although I posted solutions for these two classworks that I returned, I want to work on this because no one got it correctly. So if no one got it correctly, I blame it on myself. Okay, which means in the sense that maybe I didn't explain enough in that sense. So I see the numerator, which is x minus 1. And then I see the denominator, and that part was very clear. You did that correctly. What? X minus 1, correct? This is our agreement. First day of classes. X plus 1, x minus 1 is x squared minus 1, or x squared minus 1 is x plus 1 times x minus 1. Correct? I cannot simply simplify like I saw in your work. You cannot simplify and forget about it. Before you simplify, you must write two restrictions. Because we are talking about this function. So I have to write that x cannot equal. Right. Only then I can simplify. So I will simplify. And then indeed I get 1 over x plus 1. I immediately get my chart going. Because I may forget. I don't claim I know all my faults. I claim I know some of them. And I may forget. So negative infinity to infinity, negative 1, 0, 1, I put undefined immediately under both. Because if I don't, I may mess it up. Now I have to identify which one is a vertical asymptote and which one is not a vertical asymptote. Which one is a vertical asymptote and why?
-1.
Right. X equals negative 1 is a VA. But x equals 1 is not a VA. What is it?
Just like a gap.
Exactly. A hole with a W. No, I'm just kidding. So I have to do that right away. Then I determine the infinities left and right of negative 1. But what do I have left and right of the hole? I plug it in. What do I get when I plug it in? It doesn't matter. Left or right, it doesn't matter. So that's why I'm saying I blame it on myself because maybe I did not explain this enough. Is that clear? If the factor goes away, the function is still undefined there. The fact that it goes away doesn't mean that there is no hole in the graph.
Just means the remaining factor is what determines the vertical asymptote.
Exactly.
Okay. How'd you?
So that's
how you got the 1/2 on both sides of the
Exactly. I cannot plug this in here. I cannot plug in 1 here.
Oh, okay.
I cannot plug in 1 here. It's undefined.
Right.
Not even. It's 0 to 0 actually, which is even worse. It's an indeterminate case, and there are 7 indeterminate cases. You'll see that in Calc 1. So, but here I have to plug it in, and that's how I get the 1/2 on both sides. And remember, do not rely on the calculator. You know more than the calculator does. Is this clear so far?
So when the factors cancel, then the other one's like the vertical asymptote.
The remaining factor
Yeah, the
or
remaining
factors?
Yeah,
Yes.
remaining factors.
I don't know what. Yeah. Yeah.
And then that one's a hole.
Yes.
And then how would you? What's your thought? The 1/2? Can you?
But like if you put 0.9 in there,
Yeah. Why is it the
Less than
same value? 1/2.
would it be 1 over 1.9?
Because this is no longer undefined. There are no vertical asymptotes here.
But shouldn't it be like a different value?
No, a hole in the graph means a hole in the graph. Both sides, it's a very good question. Both sides come here.
Okay.
One cannot be here, one here. A hole in the graph means in this graph, there is a hole, which means both sides have to be the same number.
Oh, okay.
So a hole in the graph is not this. This is not a hole in the graph. This is a jump. We had that with graphing piecewise defined functions. A hole in the graph is this.
So the 1/2 is just identifying the y value. Or
The y value here and the y value here.
Right. Okay.
Because this one cannot be filled in.
Right. Okay.
Because I'm not graphing this. If I were graphing this, then I would have filled it in. It's 1, 1/2. I'm graphing this,
Right.
which is undefined at 1. Is that clear now?
Yeah.
Good. So now what is the horizontal?
Why'd you pick 1/2 then?
1 plus 1 is 2. 1 over 2, 1/2.
Gotcha.
So what type is this? Like this, that doesn't matter. What type is it?
Type 2.
Good. So what do I write here? We haven't established the signs left and right. Yes, I have to write negative 1.1, plug in negative 1.1 and negative 0.9. That's why I said the other day that this is a 3-minute thing, and you took half an hour. I said, well, what's going on? Right? Okay, so with negative 1.1, the sign is?
Negative.
Perfect. With negative 0.9, the sign is? Perfect. And plug in 0?
1.
That's it. Just 3 minutes, right? Please. So not symmetric. I have to write to show my professor that I know that this is part of graphing, but since f of negative x definitely does not equal f of x, and it does not equal negative f of x, I'm safe. I know how to graph this. It's a shift to the of what function? Right, with a hole at 1. When I graph a function with asymptotes, I have to graph what first?
Yes.
Good. So 1 was the x equals negative 1. This is an overkill. There is no need. It's already there. Perfect. So I see from 0 it drops to negative infinity. No problem. On the left-hand side of the vertical asymptote. It's coming from positive infinity. 0, 1 is this point. Now I have to be careful. 1, 1/2 is this point. And it drops to 0. So from positive infinity down to 0 with a hole and crossing the y-axis. And yes, the calculator will not do this for you. It will, but in a roundabout way. Of course, I don't know with this software how it really relates to what we're doing.
So then the domain then is going to be negative infinity to negative 1 union, negative 1 to 1 union, 1 to
Absolutely.
infinity. Okay.
Absolutely.
All right.
So let me put in the function, and you'll see in a moment. We can try to plug in 1, and you'll see what happens. So this is x squared minus 1. Close the parenthesis. And if you go to, I have to go back to table set. It's automatically. Okay. So now if you tell me plug in 1, what will I get?
Error.
Of course. Although when I graph it, let's use this zoom 6. When I graph it, it's not going to show. It's right here, but it doesn't show.
If you zoom in really, really close, it shows.
It's, maybe with this one, I don't know. So so let's say between 0 and 2 with a scale of 0.5, y minimum 0, y maximum 1, with a scale of 0.5. Yeah, it does. A tiny, tiny blip. Here it is. Scale of 0.5, this is at 1.5. Good. Any questions on this? Is this clear? Yes? These are the problems for Monday. I don't have a copy for you, so you don't have to do it. Just kidding. Where are they? Oh. Got it. So this is for Monday. And we read that note at the top. And please show all your work on scratch paper in any order you want, but I need to see all your work. Okay, you can start with the last one and whatever. The order is up to you, but just write them out every line, every step. Good. So do we have anything else? Do we have anything else for me? Now, we understand what's happening when we cancel that factor, and is that clear now? Okay, very good. So do you have anything else for me before we proceed? So I'm going to try to see 5.1 and 5.2. I strongly recommend look at these problems and ask questions. EOO, of course, means every other odd. Okay, and these 5.1 and 5.2 are included in 6.1, 6.2, and 6.3. So I'm going to go back to get back to these two only if you have questions. If not, they're a repeat. Both 5.1 and 5.2 are in 6.1, 6.2, 6.3. Okay? So we're going to cover 6.1, 6.2, 6.3. Then we're going to continue with chapter 6. I may have to jump to 5.3 and 5.4 before I finish chapter 6. We'll see in a minute. Oh, not today. I'm not going to get to 6.4 today. Ready? Anything else for me? Other questions? Okay, chapter 6. Yes, please. Any question?
No, just schedule for next week. We're supposed to have a test on 3, 5, and 6.
Is that what I said in the?
That's what it says on the syllabus, March 7th.
No.
Okay.
No. Sorry. Thank you for reminding me. I'll change it. No, I haven't even started.
Yeah, I was like, wow.
No. No. I'm 100 years behind. Okay. So the whole chapter, the title of the whole chapter is trig functions and the right triangle approach. So I'm just going to say trig functions. We're not there yet. So we start with the angle measure, which is 6.1. So we talk about angles. We're going to talk about the measurement on how we measure angles. We're going to look at the length of a circular arc and the area of a circular sector. That's all we're going to cover here. Okay? The Greeks invented trig. And because they invented trig, we kept pretty much everything that they came up with as a token of respect to them. So we call this the unit circle because the radius is 1 unit. Can anyone give us the coordinates of these points? Remember how I, quote unquote, tortured you with that agreement? Now I'm going to torture you with these points. for the next couple of weeks. Can anyone give us the coordinates of this point? Of course.
0, 1, 1, 0.
Careful. So 1, 0,
Yeah, 1, 0,
0, 1.
0, 1. Negative 1, 0.
Perfect.
And 0, negative 1.
Perfect. So there's nothing to memorize here, right? So this is pretty clear. Good. We have two categories or two types of angles: positive angles and negative angles. Again, Greeks said, well, this is the first quadrant, this is the second quadrant, this is the third, and this is the fourth. So we kept it that way, counterclockwise. And also, as they did it many years ago, they considered a positive angle going in counterclockwise on the unit circle, or any circle actually. So this is called angle alpha. We're going to use Greek letters a lot, like alpha, beta, gamma, and so on and so forth. So this is a positive angle. Any angle has an initial side and a terminal side. So for example, this angle, I'm going to call it measure beta. What is this, do you think? This side? The initial or the terminal? I know it's a silly question. Right. Initial side. I teach the classes in Arnold back-to-back, and I asked them to give me a linear function at 5 o'clock, at 4 o'clock yesterday. And then at 7 p.m. another class. They gave me the exact same function. And I showed them, I said, I don't know what's with y equals 2x plus 3. They came up with the same example. It was funny. Okay, so what about this then? This must be the terminal side. So any angle has a initial side and the terminal side. Now let's look at a negative angle. Here's a negative angle. I'm going to say it's gamma. What does this represent for gamma? Right. And what does this represent for gamma? Of course, terminal. So now, what do you think will co-terminal angles represent? Co-terminal.
I think you said would you call it?
No, what do you think will represent? Sorry about that. What do you think co-terminal angles will represent? Just give it a shot. Angles that have
Share a terminal side
and the initial side.
and
Co-terminal angles. Both. So here's an example. Here's an example of, let's say, a positive angle. So here's my alpha. And I'm going to show you a co-terminal angle with this one. An angle that starts here and does this. And I'm going to call it beta. Are alpha and beta co-terminal? Yes, they start at the same point and they end at the same point. Now, let me show you an angle co-terminal with alpha that is a negative angle. Here it is. I'm going to call it gamma. Is gamma a coterminal angle with alpha?
Yes.
Yes, but just that alpha is a positive angle and gamma is a negative angle. But they are still coterminal. Standard position of an angle. So should I write this down? I didn't write it down. That alpha and beta are coterminal, both positive. Alpha and beta coterminal angles, and put in parentheses both positive, of course.
Yeah, but we give us an example.
Yeah, but I didn't put it in writing, so later on. So alpha and gamma are also coterminal, but gamma is negative. Gamma goes clockwise. As you see, the arrow is pointing towards the terminal side. It starts here and it ends at on the same side with terminal side with shares the terminal side with alpha, of course, and the initial side.
So terminal, like, because that's where the angle terminates.
Because they start and end at the same point. They can go around the circle as many times. Doesn't matter. But they're still coterminal.
I mean, that's what terminal is coming from. Is
Yes.
terminates.
Yes. Yes. But also the initial. Both. The initial. Yes. 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 They share both. Good. Standard position of an angle is always going to start on the x-axis. So an angle in the standard position starts on the x-axis and ends anywhere you want. Let's say this one will end in the third quadrant. Angle gamma. So this is in standard position. As long as it starts on the x-axis and ends somewhere anywhere you wanted it to end on the in the circle, or in any quadrant you want, then this is in standard position. Back to the unit circle. Once again, unit circle. I swallowed the L, I'm sorry. Radius 1. And what I would like to discuss is how we measure angles. We measure angles in, number 1, degrees, and number 2, radians.
Question.
Yes,
What's
please.
the definition again for standard position of an angle?
Yes, it's the angle must start on the x-axis and ends anywhere in any quadrant. For example, this is an angle not in standard position. So let's graph an angle that is not in standard position. I'm going to call it alpha. Alpha is not in standard position because it does not start on the x-axis. So not in standard position. We measure angles in degrees and radians. In this class, we accept both, depending on the question though, but we accept both. In the next class, we only accept radians. You can forget about degrees in calculus for good.
Radiant with a T or just radiant?
Radian.
Okay.
Radian with an S. Radian and S at the end. Okay. So let's talk about the following, because we have to look at what they mean and what is the relationship between degrees and radians, and I have to define a radian. We don't know what a radian is yet, I'm assuming. Okay, so let's say I start here and I go all around the circle. How many degrees?
360.
Right, of course. So a full circle has 360 degrees. Agreed?
Yes.
Good. So now I would like you to give me the circumference of this circle with a radius of 1. So how do I determine C? If you say pi r squared, you're talking about area,
Oh, right.
right? And I should put r, right? But since r is 1, you are correct.
2 pi.
Yes, it should be times r, but r is 1. Good. So this is the same with 2 pi. The circumference of the circle is 2 pi. The circumference in degrees is 360. So, of course, I will do what to this relationship? Because there are 2 key words, at least 2 action words in this class or any math class.
Factor of something.
Right. So what would you do to this?
Simple.
By. Correct. So from now on and forever, we have to remember that pi radians is the same with 180 degrees. I still haven't defined what a radian is. But this is the relationship between degrees and radians. 180 is the same thing with pi. Okay, let's come back to the unit circle for a moment, and then I'll define a radian. Back to the unit circle. I need to identify these spots again, not as ordered pairs. I know that this is, let's do it as ordered pairs again. This one is, yes, this one is, right, this one is, and good. I want you to give me here the number of degrees of an angle that starts here and ends here. 0. Okay, now I would like for this angle, meaning starts, has a standard position, starts here but ends here. Perfect. An angle that starts here and ends here. And the last one starts here and ends here. Very good. Now, what did we say 180 equal to? Good. So this is 180 degrees, or pi. When we say pi, we don't really need to. It's understood. It's pi radians. You don't have to write it. So when we say the measure of angle alpha is 4, we don't mean 4 degrees unless I say 4 degrees. If we say alpha measures 4, I mean 4 radians. Okay? Good. So how many radians is 0 degrees? Right. 0 radians. How many radians is 90 degrees if this is pi? Exactly. Finally, 270, look here. 1 pi over 2, a second pi over 2, and a third pi over 2. So 270 degrees is the same with?
3 pi.
That's it. I'm back to 0, and 0 is also the same with? That's it. So from now on, when we say pi over 2, we mean 90. When we say 180, we mean pi. When we say 3 pi over 2, we mean 270, and so on and so forth. Okay. Let me define radians, and then we'll see how much is 1 radian and how much is 1 degree in radians and how much is 1 radian in degrees. Okay? So, radians. Or what is a radian? And I have a little prop for you. Here it is. Is this, and bear with me and say yes, I know it's not.
Yes.
Is this the length of a radius?
Yes.
Is this the length of the radius?
Yes.
No, please don't say no.
Oh, no.
Yeah.
Okay. You realize what I just did? Paul?
No.
No. Okay, here it is. Is this the measure of the radius?
Yeah.
And I put it on the circle. Is this the same measure? I didn't.
Yeah.
Yes.
Okay. So this is an angle of 1 radian. So what is 1 radian? What is 1 radian? Is an angle that we say subtends. Subtends an arc equal to the length of the, that's why it's called radian.
So what's it?
The measure of an angle in standard position, right? A central angle in standard position. It doesn't have to be in standard position. So a central angle that subtends an arc that has the same measure width of the circle. Now if you say how much is this, we're going to determine it. Because if you tell me graph 2 radians, ooh, I will say, okay, 1 radian is roughly 57 degrees. I'm going to show you why. And then times 2, 114 degrees. I know exactly where to plot it. But if you tell me plot or show me an angle of 2 radians, I'll say, oops. I'll multiply roughly 2 times 60, and I know, oh, it's roughly 120. Okay? So again, a radian is a central angle that subtends an arc of equal measure with the radius of the circle. That's what a radian is. Good. So now we know that 180 degrees equals pi, or if you want pi equals 180, doesn't matter. But I want to know how much is 1 degree. What do I do to both sides of that equation to find out not how much is or how much are 180 degrees in radians, but how much is 1 degree? Both sides by? That's it. How do I determine now not pi radians? I want 1 radian. I want to know how much is 1 radian in degrees. What should I do to both sides of that equation?
Since pi equals
180 over pi. So when you plug in this in the calculator, you will see it's roughly 57 degrees. So let's plug it in. So 180 divided by pi. Here's your pi right here, hidden under the caret with the second key, 57 degrees. So now, if you say graph an angle in standard position of 3 radians, I'll say, oops, okay, 3 times 60 is 180, but it's somewhat short. Yes?
So the first equation, or It's degrees to radians, right? Pi over 180.
So 1 degree is pi over 180.
Yeah, that's it. And then
So this is going to be the answer for 1 degree into radians.
yeah, degrees
And this will be 180 over pi will be 57 degrees. So again, if you say graph alpha equals 3, which has to be understood as 3 radians, I will say, okay, 57 is roughly 60 degrees. 3 times 60 is 180, but this is short 3 degrees. 3 times 3 is 9, so 180 minus 9 must be 171. So I'll say here, be happy. This is alpha equals 3 radians. And stop asking me to graph angles in radians because it's more difficult. It is. Good. One formula called arc length. Arc length. This time this is not the unit circle. A radius r. A central angle in standard position of theta. And this arc length is lowercase s. So the arc length is denoted by lowercase s. And the formula is theta multiplied by r. Theta must be in radians. We'll have examples in a minute. In the circular sector, let's go back. Let's say I have this angle. It doesn't have to be in standard position. So let's say I have this angle, and it's theta. And I want to determine this area. The radius is r. I didn't mean to write s. I'm going to delete it. I meant to write a. Sorry. Don't write s. The area. The area of a circular sector is 1/2 r squared times theta. Again, theta must be in radians. It's area, right?
Yeah, I'm just making sure.
Yes, it's r squared. Yes, because it's area. Good, so let's look at on page 440. '54. Page 440. 54. Find the length of an arc that subtends a central angle of 45. So this is 45, right? Right in the middle, half of a quadrant, right? This is 45 degrees. And they ask us to find s, yes. And the radius is 10. That's one question. And then I would like to look at an area, and then maybe convert one into the other, degrees into radians and radians into degrees. So the formula is r times theta, where theta is 45 degrees. However, I cannot plug in 45. What do I have to do? Convert into radians. Very good. And let's do this just now because I need this forever. Okay? So what was this angle? radians.
That was 5 and 2.
Very good. What will be the half of pi over 2?
5 and 4.
That's it. So please remember, we need this forever. Pi over 4 or 45 degrees is the same thing. So then S will be 10 multiplied by pi over 4. And whatever you give me, I'll put it in. Or should I do it? So 10 multiplied by pi and divide everything by 4. I got 7.85. Whatever the measurement is, unit is.